Hello, welcome to this Unreal Engine video. I'm the Festmaster, and today I'm actually going to be trying something a little different. It's not a tutorial. I'm not sure what to call it other than a study. Basically, what I'm going to do is propose a problem or interesting thing in Unreal and explain how I came to a solution. And today what I'm going to be talking about is texture stitching. So as you can see here, I've got a material with a bunch of textures that look like they're from Minecraft laid out on it. And the interesting thing is, this is all one image. It's one image. I can show you that I can pull up the material here. It's called display. It just has a single texture and a very high roughness value. And the interesting thing is that if I go over to a different content browser, I have all of these images as separate textures. And so what I wanted to do is basically combine all of these into one texture so that I can display them all on the same material. This would be very useful for making a voxel world like Minecraft. In fact, that's where I got the idea. So basically, the idea is these all need to be compiled into a tile map so they can be referenced by one material, and then if a model is going to use a particular texture, it would be a dynamic model so that you can actually set the UV coordinates in code, and it would work exactly like a 2D tile map. And so I did that through a couple things. First, I set up 3 render targets. One called RT Final, one called RT Temp, and the other RT Transpose. I also set up a black pixel image, and then a material for that image. Very simple. I set up my display material. And then I also had a bit of code, but I'll show you that later. So the first thing I did was I needed a material to stitch a row of textures together, because that's what I decided to do. I'd do a row, and then I'd combine those rows in sort of a similar fashion. But I wanted to do it one row at a time, and so I had to make a stitching material, just a computational shader to actually compile the materials together. So what I did is I got all 8 tiles that I wanted as parameters and named them 0 through 7. And then I played around with the texture coordinates a bit to squish each of these. So if I will start previewing this node and put it on a cube, it is squished. So if I undo that, you'll notice that it looks like it's a regular image, and then I connect this and it's been squished to 1/8 of its distance. And I do that to all of them. And then I made a material function here that's a slot selector, and then plugged that into each of these. So if I open this slot selector up, you can see that it is incredibly messy, because this was the only way I could figure out how to do this, and I spent quite a while trying to figure this out. And so what I use is an image here that, let me just pull it over, is, oops, it's a 1 by 8 pixel image, so it's very small. And I'll just scale the fit again. It's got a single black pixel, a red pixel that's 0 green, 0 blue, and like 0.5 red. The same with green and blue, so these are all like half of their each color value, and then a full of each color value and a white pixel, to get a total of 8 pixels on here. And then in the slot selector, I basically use math to isolate out each individual row. So I've got like the black pixel here, then I start previewing this node. I've got like that first red one, so on and so on. Like here I've got another row. And then I added a scaler so I could actually individually select a row to come out of a specific output, and then just used a bunch of ifs, and I don't actually need that if down there, but used a bunch of ifs to decide which one to come out. So if I start previewing this node, then I come over here and change this, so this will be slot 0, slot 1, slot 2, slot 3, and so on. As well as each slot sort of coming out of its own output, which is what I have here. So I've got slots 0 through 7 going into a lerps, sort of this trickle down fashion. I don't have any information coming in here, and then it adds a slice of the first texture, then this one will add a slice of the second texture. This one adds a slice of the third texture, and so on until it's finished. And then I have this sort of thing, one strip. And so I'm like, great, that works. I'll set up a loop where I get that texture from a texture from a bunch of textures, get its name, and add it to this material, which, if we just go in here, this material is just a dynamic instance of that stitching material. So I'm just looking very limitedly at this chunk of code right here, and sort of that. So I get, for each 0 through 7, I add that to the parameter based on that index name. So I get a material with 8 textures in it that I can then work with. But how would I add things vertically? So I wrote this material, and this basically right here just rotates the UVs going into our slot selector by I believe from negative 90 degrees or so. Rotators work in radians, which is why I had to do pi and division in addition, a slot parameter for that index, and then an index to basically add. I get a base image, and then I add to it a strip, and then I compress that strip to 1/8 of its height so that it becomes a square again. And then I add that out. So I'm great. But what about when I don't have textures to add? I just used a black texture. So once I've looped through all the textures, I've got my strip. Complete that. I draw that to this temporary render target. And then I set the scalar parameter of my vertical material, which, if you look, is just the vertical slice adder material. And then I draw that material to the transpose render target. The transpose render target is used simply because this material uses this RT final as an input, and so it cannot be drawn to it. So I have to have a third render target and material to go through to do that. So I write it to a transpose render target, which sort of has its own material RT transpose mat, which is just the transpose render target. If I click here, you see that's the transpose render target just being pumped into the emissive. And then I write to my final render target using that transpose material. And then I'm like, well, I should also have the ability to clear these. So I added another event that I can call in the editor where I just draw a material to the render target, and it's a black pixel material. It's just straight black. And so if I grab my little thing here, I can reset it, all black images, and then render out a new set of tiles. And so that's how I managed to solve dynamic tile or texture stitching and creating a tile map inside of Unreal Engine. So thank you for watching this Unreal study, and I will see you next week.